Humid continental, cool summer. Picture vast forests of spruce and fir, interspersed with crystal-clear lakes and rivers teeming with life. This is the humid continental climate with cool summers, a zone where winter's grip lingers long and summer's warmth is a fleeting visitor. Found in the northern hemisphere, typically between 50 degrees and 60 degrees latitude, this climate is characterized by long, cold winters and short, mild summers. The average temperature of the warmest month is below 22 degrees Celsius 72 degrees Fahrenheit, while at least 4 months average above 10 degrees Celsius 50 degrees Fahrenheit. Precipitation is moderate, ranging from 600 to 1,200 millimeters, 24 to 47 inches, annually, and is fairly evenly distributed throughout the year. This climate fosters dense boreal forests, also known as taiga. These forests are dominated by coniferous trees adapted to the short growing season and cold temperatures. The understory is often carpeted with mosses and lichens, creating a landscape of subtle beauty. The harsh winters and short summers have shaped unique adaptations in both flora and fauna. Many animals migrate or hibernate to survive the long winters, while plants have developed strategies to maximize growth during the brief warm period. Societies in these regions have developed ingenious ways to thrive in this challenging environment. Traditional cultures have deep connections to the forest and its resources, while modern economies often revolve around industries like forestry, mining, and increasingly, ecotourism. This climate zone is particularly vulnerable to climate change. As global temperatures rise, the distribution of plant and animal species is shifting northward, altering ecosystems that have existed for thousands of years. These changes have far-reaching implications for biodiversity, resource management, and human communities. Understanding the humid continental climate with cool summers is crucial for global climate dynamics. These regions play a vital role in Earth's carbon cycle and influence weather patterns across the northern hemisphere, underscoring the interconnectedness of our planet's climate systems. Subarctic. Imagine a land where winter reigns supreme, where the northern lights dance across star-filled skies, and where life has adapted to extreme cold. This is the subarctic climate, a zone that tests the limits of survival and showcases nature's resilience. Found in high latitudes, typically between 50 degrees and 70 degrees north, the subarctic climate is characterized by long, severely cold winters and short, cool summers. The average temperature of the warmest month is between 10 degrees Celsius and 22 degrees Celsius, 50 to 72 degrees Fahrenheit, while winters can see temperatures plummet below -40 degrees Celsius -40 degrees Fahrenheit. Precipitation is generally low, ranging from 200 to 600 millimeters, 8 to 24 inches, annually, with much of it falling as snow. This harsh climate supports the boreal forest or taiga, the world's largest terrestrial biome. These forests are dominated by cold-tolerant evergreen conifers like spruce and fir, interspersed with deciduous trees like birch and aspen. The forest floor is often covered in thick moss, hiding a layer of permafrost beneath. Life in the subarctic has evolved remarkable adaptations. Animals like caribou and moose have specialized features to cope with deep snow and cold, while many birds migrate vast distances to avoid the harsh winters. Plants have developed strategies to photosynthesize under low light conditions and protect themselves from freezing. Cultures in these regions have developed unique ways of life, deeply connected to the rhythms of this extreme environment. Indigenous peoples have thrived here for thousands of years, their traditional knowledge offering valuable insights into sustainable living in harsh conditions. The subarctic is experiencing some of the most rapid warming on Earth. As temperatures rise, permafrost is thawing, altering landscapes and releasing stored carbon. These changes have global implications, potentially accelerating climate change worldwide. Understanding the subarctic climate is crucial for predicting global climate trends. As a sensitive indicator of climate change, the subarctic serves as an early warning system for our planet, reminding us of the delicate balance of Earth's climate systems. The rapid transformations occurring in this region highlight the interconnectedness of global ecosystems and the urgent need for climate action. As we study and protect the subarctic, we gain invaluable insights into the resilience and vulnerability of our planet as a whole.
Click subscribe to this channel to get more topics you love.
Ice cap. Envision a world of perpetual winter, where ice and snow stretch as far as the eye can see, and where the very ground is frozen solid year-round. This is the ice cap climate, a zone that represents Earth's ultimate cold extreme. Found in the polar regions and on the highest mountain peaks, the ice cap climate is characterized by year-round freezing temperatures. Even in the warmest month, the average temperature never rises above 0 degrees Celsius (32 degrees Fahrenheit). Precipitation is minimal, often less than 250 millimeters (10 inches) annually, falling almost exclusively as snow. Despite its inhospitable appearance, the ice cap climate plays a crucial role in Earth's systems. These vast ice sheets reflect sunlight back into space, helping to regulate global temperatures. They also store enormous amounts of freshwater, influencing sea levels and ocean currents worldwide. Life in the ice cap climate is sparse but remarkable. In polar regions, algae grow within and beneath the ice, supporting a food chain that includes fish, seals, and polar bears. In Antarctica, emperor penguins have evolved to breed during the harsh winter months. Microorganisms known as extremophiles thrive in seemingly impossible conditions, offering tantalizing clues about the potential for life on other icy worlds in our solar system. Presence in ice cap regions has historically been limited, but these areas have long captivated our imagination and scientific curiosity. Research stations in Antarctica and Arctic expeditions continue to yield valuable data about Earth's past climate and potential future changes. The ice cap climate is particularly vulnerable to global warming. As temperatures rise, ice sheets are melting at unprecedented rates, with far-reaching consequences for global sea levels, ocean circulation patterns, and ecosystems worldwide. Understanding the ice cap climate is crucial not just for climate science, but for our comprehension of Earth as a complex, interconnected system. These frozen realms, seemingly remote and lifeless, are in fact integral to the health and balance of our entire planet. Cold desert. Picture vast, windswept plains of gravel and rock, where bitter cold replaces the searing heat typically associated with deserts. This is the cold desert climate, a zone that challenges our perceptions of what constitutes a desert. Found in continental interiors far from moisture sources, or in the rain shadow of high mountain ranges, cold deserts are characterized by extreme aridity combined with cold temperatures. Annual precipitation is typically less than 250 millimeters (10 inches), and average temperatures in the coldest month often drop below freezing. Despite the harsh conditions, cold deserts support a surprising diversity of life. Plants and animals here have evolved remarkable adaptations to cope with both cold and drought. Many plants have developed deep root systems to access underground water, while animals often have specialized features to conserve water and stay warm. The landscape of cold deserts is shaped by wind erosion and temperature extremes. Wind-sculpted rock formations, vast gravel plains, and occasional sand dunes create an otherworldly beauty. In some cold deserts, patterns in the ground caused by repeated freezing and thawing create stunning geometric shapes visible from the air. Human interactions with cold deserts have been limited but significant. Some of these regions contain valuable mineral resources, leading to mining activities. In other areas, traditional nomadic cultures have developed sophisticated strategies for survival in these harsh environments. Cold deserts play an important role in global climate dynamics, influencing atmospheric circulation patterns and serving as sensitive indicators of climate change. As global temperatures rise, some cold deserts are experiencing shifts in precipitation patterns and vegetation cover. Understanding cold desert climates is crucial for several reasons. They offer insights into the extremes of adaptation, provide valuable data for climate modeling, and present unique challenges for conservation and resource management in a changing world. Microclimates. While we've discussed broad climate zones, it's important to recognize the existence of microclimates, small areas where the climate differs from the surrounding area. Microclimates can occur due to various factors such as topography, vegetation, bodies of water, or urban structures. A south-facing slope in the northern hemisphere may be warmer and drier than a north-facing slope in the same area. A forest creates its own microclimate, with higher humidity and lower temperature fluctuations compared to nearby open areas. Urban areas often have higher temperatures than surrounding rural areas, a phenomenon known as the urban heat island effect. Understanding microclimates is crucial for agriculture, urban planning, and conservation efforts. They can provide refuges for species as climate change alters broader patterns, and offer opportunities for specialized agriculture or energy-efficient building design. Climate change impacts. It's crucial to note that the boundaries and characteristics of climate zones are not static. As global temperatures rise due to climate change, we're observing shifts in climate zones. Tropical climates are expanding poleward, affecting biodiversity and agriculture in subtropical regions. Arctic and subarctic zones are warming at a faster rate than the global average, leading to rapid changes in these sensitive ecosystems. Some regions are experiencing increased frequency and intensity of extreme weather events, such as heatwaves, droughts, and heavy precipitation. These changes have profound implications for ecosystems, agriculture, human settlements, and global biodiversity. Understanding how climate zones are shifting helps us predict and prepare for future changes. Transitional zones. Between major climate zones, there are often transitional areas that share characteristics of neighboring climates. These ecotones can be particularly rich in biodiversity as they support species adapted to multiple climate types. The transition between Mediterranean and semi-arid climates often supports unique plant communities. The forest tundra ecotone is a sensitive indicator of climate change, with tree lines advancing as temperatures warm. These transitional zones are often at the forefront of climate change impacts, making them important areas for research and conservation efforts. Elevation and climate. As we move up in elevation, climate changes in ways similar to moving towards the poles. This creates vertical climate zones in mountainous regions. Lowlands might experience tropical conditions, mid-elevations could have temperate climates, high elevations might have alpine tundra. This vertical zonation creates unique opportunities for biodiversity, as a single mountain can host multiple ecosystems. It also presents challenges as climate change forces species to move upslope, potentially running out of suitable habitat at the highest elevations. Understanding these nuances in climate classification helps us appreciate the complexity of Earth's climate system and the challenges we face in a changing world. It underscores the interconnectedness of global climate patterns and the importance of comprehensive approaches to climate science and policy.